Hey guys, welcome to another video. So today we're going to continue on with the nice question series. Today's question comes from the advanced syllabus from James Rew's 2023 paper. The topic is calculus optimization maxima minima. So I thought it's a nice question, not too hard, not too easy, just nice. So let's get started on the question. So, before we begin, once again, as always, can you please, if you haven't already done so, like the video, subscribe to the channel, and tell your friends. Thank you. Let's go. So now this question, I think it was the second last question in the test. So yeah, it's considered to be somewhat challenging. It's James Rew's at the end of the day, so it's not a walk in the park. So I see what we got here. So we have a semicircle, right, with PQR as a right angle triangle. R is a variable point, right, that moves along the circumference. S is a point that lies on PQ, so that SQ is K, which is a constant, times QR, and PQ is D. So you know what, I'm going to label that PQ. So this line here is D for diamond, I presume, and PQR is that's given in the question. Okay, that's alpha there. Okay, so let's see what we have to do, right? So show that the area of SQR. Now, where's SQR? That's this triangle here, right? Okay, this triangle. SQR equals that. Okay, differentiate and then greatest possible area. Okay, classic question. So part A is usually now. Whenever I say this to my students, I always say to them, if you can't do part A, use it for part B. So differentiate it and still go on with the optimization steps, right? Differentiate, and then if you can't do part B, use it to do part C, where we basically solve the derivative, all right, and then show that it's maximum to finalize the question. So I guess what I'm trying to say, it's a 3-step with 8 marks, right? That's a lot of marks in a 2-unit paper. If you can't do part A, use it to do part B. If you can't do part B, use it to do part C, sort of thing, right? So let's do this question fully. So in this triangle here, now, feels like we're going to use area of a triangle, right? Using trigonometry. Now, I feel like this side, let's say I've got the angle, okay, that's a dead giveaway. Then I probably need to find what this side is, right? This side here, and what this side here is as well, right? Yeah, I need those 2 sides actually. I don't need arrows, I'm not doing vectors, right? Just these 2 sides here, right? That's the triangle that I want to deal with. So I am going to come over here. Now, firstly, let's get an expression for QR in terms of, now, can you see in the thing I have to prove there's only Ks, Ds, and alphas. So there's no like SQ or whatever. So just everything should be expressed in terms of those variables, right? So now I have a right angle triangle that looks like P, Q, and R right now. And I know that this is alpha, and I know that this is D, right? I want to find an expression for this side, right? Just using Sokotoa, right? So what's that? Cos? The cos alpha is RQ all over D. So therefore, RQ is D cos alpha, right? Going to use that, right? So I've got that one, and I need this side here. Now, I know it actually tells me, right? So I know that SQ is equal to K times QR. K, QR, well, maybe I should say QR, not RQ, because do it in alphabetical order, so everything's consistent. QR, yeah, and then I'm just going to plug this guy into here, I believe, because that's what's giving the question, right? Cool. So therefore, SQ would be what? KD, now which, yep, KD cos alpha, right? All right, I've got my 2 sides, got my angle. I can use therefore, yeah, area of triangle SQR, right, which is capital A, equals to. Now it's a half times pink side, right? So times QR times that. So half times D cos alpha times KD cos alpha times, now the formula sine alpha. Right? Now, if you simplify that, I think you got it, right? For 3 marks. It's not too bad, actually. Therefore, area is now, how did they want me to state it? Did I put a half in front? Yep, half KD, perfect. Half KD, yep. Half KD squared, cos squared alpha, sine squared alpha. That's exactly what they want. Not a bad start, right? Not a bad start. So that's part A. And now it feels like there's a bit of heavy calculus. I just got to differentiate that, right? So I'll come over. You know what? I'm just going to start fresh page, right? So start fresh page. Let's go here, get rid of that. Okay. Should I say get rid of that? I need the last line, don't I? So, you know what? Get rid of everything else bar the last line. And I'm going to use it to start my puppy. Okay. Okay, let's do this. So, get rid of this. Don't need the box, all right? So, part B. I'll start with that. So, dA, D alpha. Let me just check that's exactly what I want me to do. dA, D alpha. Okay, cool. Okay. Product rule feels like. So, that guy's a constant, but that guy there is U, and that guy there is V, right? So, the constant here, so leave it untouched, right? That just stays there, hangs out, right? So, off to the side, guys. U dash, that's the chain rule. So, 2, oh, careful there. So, it's 2 cos alpha, and then multiplied by derivative of cos alpha, which is negative sine alpha. So, U dash is going to be negative 2 sine cos. Yeah, and then V dash. Oh, there's no squared. Don't know why there's a squared on the side. I don't think there is. Let me just check. I think so, right? No, and certainly not from my working out. I remember there was only one sine. Yeah, should be no squared. Okay, perfect. Okay. Oops. Okay, zoom in there. Okay. So V dash is derivative of sine, which is just cos. Perfect, right? All right. Got my tools to do product rule. So the green part, you know what? I'm just gonna factorize it out, right? So it sort of hangs outside. I'm going to move this guy slightly more to the right. I have more space. Okay, U dash V. So minus 2 sine cos times sine. So that's like minus 2 sine squared cos. And then plus cos times, that's cos cubed. Oops. Now, let me just make sure. Does that look like what I want? You know what? It's pretty close, right? What do I do? Oh, they probably use a bit of identities, right? So is that right? Yeah, so just got to apply a bit of identities to this bit. So identities, because the thing that they want me to prove has no signs, just causes. So I can see there's a sine squared there. So I'm just going to apply the identity of what is it, 1 minus cos squared to that. So it becomes I'll put minus 2 cos outside, 1 minus cos squared like that, plus cos cubed, and then collect my like terms. No. Okay, rainbow expand that. That's minus 2 cos. Is that what I want? Yeah, perfect. And then okay, perfect. I can just go 3 cos cubed minus 2 cos. Perfect. And that's it. So therefore, dA d alpha is that. All right, exactly what I want. 2 marks, right? Yeah, I think that's fair because it's like a pretty involved sort of product rule with trigonometry, and then greatest possible value of the area. Okay, so I'll go part C, start with that, set that to 0, right? So I'll go half KD squared multiplied by, you know what? I'm going to factorize to make this a bit easier. To factorize a cos alpha out. So that's 3 cos squared alpha minus 2 equals 0. Now, for all intents and purposes, the constant goes away. So I sort of get like 2 lots of solutions. All right, I've got cos alpha equals 0, or I got cos squared equals to 2/3. Yeah, so cos alpha equals to plus minus root 213. Yeah. Now, coming back to the diagram, right? The diagram has alpha within a right angle triangle. So alpha has to be bigger than 0 and smaller than 90, right? So that rules out a number of the 3 answers I got here, 0 plus minus root 213. It can't be 0 and it can't be negative, right? So therefore, right, cos alpha equals a root 213 because alpha has to be between 0 and 90 degrees, right? Has to be, right? Diagrammatically. So that's my answer. Now I got to test it. So let's see. If that's my first derivative, now do I want to be heroic and put no, I'm just going to use a table method, right? So test for max min. Right. Now, what is that on your calculator? Remember, put everything in radians when you do this, right? Square root 213. So it's approximately let's see. So shift cos. That answer. Oops. I've got to put that in radians. So I've got one here in radians actually. Yep, perfect. So shift cos and root 2 divided by 3. What does that give me? 0.6. Okay, cool. So when I test this, right, and my answer for alpha, right, in here it's shift cos. Right, if I run it, or inverse cos of root 213, which is approximately 0.6, right? So maybe I'll go 0.5 over here and 1 over here, right? And this is like my derivative, so dA d alpha. So if I sub that in, I think definitely you get 0 there. Guys, if you sub 0.5 in, I think you get like 0.27. Oh, there's the constants as well. So I'm just ignoring the constants, right? So maybe I'll go 0.27 and then multiply that by half kd squared, right? Because that's all positive, so it doesn't matter. And if you punch 1 in radians, you get negative 0.61 times half kd squared, right? It's just that when I because what I'm trying to do is basically sub these values into the derivative, right? And there's always like this half kd squared out here that I really don't care about when I do these numbers. It's the value of subbing into the alphas, right, that I care about, right? Now, what does that mean when I do sub it in and it gives me that sort of those values? It basically means it goes up gradiently, that guy negative, therefore, yeah, max area when alpha equals to cos inverse of root 213. Yeah. Now, let's answer the question. So now that I've proven that max area exists, they want me to find the max area. So I need to sub that into, right? So take this and sub that into the original, right? Sub it into there. And guys, when you do, let's see what I get. Yeah, let's see what I get. Actually, no, let's be smart about it. Well, should we give the exact answer? Yeah, I think we can get the exact answer, right? So let's see. Let's be smart. So I'm gonna try to do this. So I'm just trying to zoom in, struggling a bit. There we are. Okay. Now, off to the side, right? Because like when I sub it in, there's like cos alpha and sine alpha. So if I get that guy there as the answer, so that's like cos alpha equals to root. So I'll go root 2 on root 3, right? So using a right angle triangle, just to get the value of sine theta, cos is like, if this is alpha, this is root 2 and this is root 3. By Pythagoras, that's like 1, isn't it? 3 minus 1, yeah. So therefore, sine alpha is 1 on root 3. I'm going to use those to sub in. So therefore, max area equals to, right? Now I definitely have a half KD squared, right? That's in front, I believe. In formula, we'll scroll up. Okay, cos squared times sine. So then I'm going to multiply this by cos squared, the square of root 2 on root 3 squared multiplied by 1 on root 3. So therefore, max area is, what's that? 2 on top, that cancels out 2. 3 root 3 on the bottom, is that right? Yeah, so final answer, KD squared on 3 root 3 unit squared. Guys, how was that? So, I mean, this question, not too bad, I think. Just a playthrough. It's always a bit tricky when there's cos and sines involved. Hopefully that was okay. Guys, let's leave it there. If you like the video, please subscribe to the channel, like the video, and tell your friends. Thank you very much. See you at the next one.